This is problem 89 from chapter 13. The boy of mass 40 kilograms is sliding down the spiral slide at a constant speed such that his position, measured from the top of the chute, has components. R is equal to 1.5 meters, so that's the distance from the axis to the boy. Theta is equal to 0.7 times t in radians when t is in seconds. And z is equal to negative 0.5 t, where it's negative because they said they're measuring the position from the top of the chute, so he's going downwards. We want to determine the components of the force which the slide exerts on the boy at t is equal to 2 seconds, and we're to neglect the size of the boy. So we have the mass, we have r, we have theta, we have z. We want to find the components of the force, which we will do using Newton's second law when t is equal to 2 seconds. Before we use Newton's second law, we need to find the radial, the transverse, and the z components of the acceleration. I have the equations for them here, which came from equation 1232. So what I would like you to do is use r, theta, and z to find r dot, theta dot, z dot, then r double dot, theta double dot, and z double dot, and then find the components of the acceleration. So please pause the video now and do that, and when you have finished, you can continue watching the video. Okay, so r is constant, so r dot is equal to 0, and r double dot is equal to 0, theta dot is equal to 0.7, z dot is equal to negative 0.5, that just comes from taking the time derivative, and then theta double dot and z double dot are equal to 0. So we have, for the radial component of the acceleration, r double dot is equal to 0, minus r, which is equal to 1.5 times theta dot squared, which gives us negative 0.735. And then for the transverse component of the acceleration and the z component of the acceleration, we have 0. We could draw a free body diagram for the boy. We would have the force that the slide exerts on the boy, which I'm not quite sure yet what direction that force would be going in, but it helps now that we figured out the acceleration, so we know there's no transverse component. And we also have the force of gravity acting downwards. So force of gravity is definitely acting downwards. Then we have another component another force, which is the force that the slide exerts on the boy. So something like that. Looking at the equation sheet for Newton's second law, we have the sum of the forces in the radial direction is equal to the mass times the acceleration in the radial direction. The acceleration in the radial direction is negative 0.735. And the only other force we have is the force of gravity, which is just acting in the negative z direction. So we have Fr, which is the radial component of this force, is equal to the mass of 40 times negative 0.735, which gives me negative 29.4 newtons, and the negative sign here means that the force is acting inward. And because it did ask me for the component of the force, I would leave that negative sign there. So that is telling me that it's pointed inward. The force of gravity does not have a component in the transverse direction, and because the acceleration in the transverse direction is 0, the component of the force of the slide acting in the transverse direction is also 0. Then, when we look in the z direction, we have the sum of the forces in the z direction, which would be the z component of the force of the slide on the boy, minus the force of gravity is equal to the mass of the boy times the acceleration in the z direction, which is 0. That means the z component of the force is equal to the mass of the boy times g, which is 392 newtons. So that gives us our answers. I guess this is an answer also.